Okay, let's continue watch the phone interview example.
The number of islands is one thing. We'll start that at 0.
Can I interrupt you here?
What's that?
Can I interrupt you? I want to ask a question. Looks like you have already built an algorithm. Can you tell me about your algorithm first?
Sure, yeah. So my algorithm is going to go through the matrix row by row,
Uh-huh.
keep a running total of the number of islands that it has encountered.
Okay.
And it's going to do that by keeping track of the previous row as well as the current row,
Uh-huh.
comparing the island positioning in each to determine whether the island is contiguous or not.
Okay. So your algorithm can find out the contiguous island across different rows. Like a first row has first row has one connected island, and the second row will have an island. And can your algorithm find out that those two islands are connected?
The algorithm will have to find out whether those two islands are connected by knowing the position, like the previous row and the current row.
Okay. Position of the previous row and current row. When you first take a look at the first row here, and you will remember your algorithm will remember that the column one and column two are the islands for the row one, right?
Yeah, right. Well, so
How about
I think
this?
what I was planning to do was that it would keep track of, which positions the islands were in, and then which positions the islands currently are in the
Okay.
current row. You know what I
Okay. Good. How about this example?
mean? So you've got more potentials for islands. So you need to know where in that row the island is, right?
Yeah.
Mm-hmm.
Like in this example, what your function will return is 2 because there are 2 islands, and then each row has actually multiplying islands.
Oh, I see what you're saying. Got it. So there's potential for more islands in this. Yeah. Got
Yep,
it.
yep, yep.
Okay, so you need to know the edges of the islands, I guess, too, right? To know
Okay.
which. So each island has its edges as well as its contiguous mass. Yeah, so you need to know what island you have. Okay. You need to know which the islands that you have as well as their edges, and then I guess so do you need to know the edges? Yeah, I guess you need to know the edges because you could end up with one island if you connected them with the next row, right?
Yep.
No, that's pretty cool. Okay, so yeah, you need to know the edges, and you need to know whether you're filling in the edges to connect to. Well, this is a tricky one. Okay.
Or can you think of some different type of algorithm? Well, let's say that you are looking at 3, 0, like your first row, third column. Then there is an X there. And then you can see that there is another X on your right and there is another X on your bottom. And
Sure. It's just like creating contiguous masses, right?
yes.
So I see. So for given a matrix, really start with any position and determine whether, like, basically traverse the path until you reach the edge of it, right?
Yep.
But you want to make sure that you've covered all the positions, right? Yeah. So if you get to that, okay. So you're really covering the masses, but how do you make sure that you've covered all the spaces? Let's see.
Yes.
I guess so there could be one. Okay, so if you every position that you've seen or every position that you visited,
Uh-huh.
and you iterate through the entire matrix, but you check whether you've already seen it or not, then you
Yes.
should be able to go make sure you've hit all the positions, and then you're keeping track of your islands as you go.
Uh-huh.
So as you're going through your island, though, you need to make sure that you're getting to the entire end of it, right?
Yes.
Okay, so as you're traversing through, you hit your first island. As long as you top down, you can come back, traverse back. So once you've reached that, you've hit your first island, and you're going straight across until you get the next island. Come back. Actually, for each position, you check all the way around it, right? You check
Yes, yes.
down, backwards. I guess you don't need to check up if you're always going through. But can you guarantee that you're always going to be going through the proper way? And you've seen, yes, I think you can. Well, either way, for the first pass, we'll check all the way around and see whether it's a part of the island or not, and mark that position as being part of the island. So we'll have to keep track of the islands that we've seen and all the points that represent those islands, as well as all the points that we've seen, and whether or not they're an island. And then iterate through the entire matrix. And I think with those three structures, we should be able to figure out how many islands there are, because at the end of the day, we can just count the number of entries in the island structure.
Yes, basically what you are going to return is the number, like a number of islands.
That's right. Yeah.
Yep.
So
okay. Yeah, let me tell you a little bit more about. Like this is basically a graph search algorithm, and this is the depth first search.
Okay. Depth search.
Yeah.
Depth first search.
Yeah, depth first search. Yeah. So at each point, if you find an island, hey, this is an island, and I want to mark everything, every connected islands with some value, basically. Yeah. And then you want to come back to the starting location by using some
recursion.
Yes, basically, I was about to say queue, and no, stack actually. Yes, but when you call a function, it internally creates a stack there that calls stack, so you can easily come back to the function that calls to mark every visited places. You understand?
Yeah, makes sense.
Yep.
Okay, so it probably makes sense to operate on the base level, right? So the function that's going to check, it's like the depth search algorithm. It's going to see. It's island. Yeah, so maybe it is island for a point. So that's one thing that we'll need here. We also need the ability to check nearby neighbors for each. So given a search, but check neighbors, let's call it that for now. And we want to actually store, so I don't know what, let's see, we'll keep track of the scene points as well as the island points. Do we need the island points, actually?
Well, I'm not sure. I don't think so. Or actually, you don't need the scene points too.
The reason I wanted to track scene points was to see. Well, I guess you're just checking whether it's an X or not. That's not very much work.
Yeah, okay. Actually, you need to track all the scene points, but why don't you use just matrix? And because it is already copied, and you have a reference to the matrix, and you can
do something. Update it as you go, right?
Yeah.
Okay, so the X and Y locations. We'll say that X. So I guess point is going to be more of an object now that has. Let's say the point is an object. I'm sure we've got something like this, but. So what we want to do is we want to check all the way around, really. Okay, so I'm going to do this. So the left point, point, and let's call it this, neighbors. Fifth point is island. We want to set matrix. Matrix. Let's see. Well, I guess we should have a structure for this too now. Matrix.
Okay.
Going to take, let's call it maybe just rows. Actually, we'll just initialize it. And then we can have an add row maybe. Kind of thinking out loud here, sorry. Oh, but we need to know the position of this row too, right? So I think it needs to be initialized this way.
Let's say that you have a class already implemented a class called matrix, and that class does probably almost everything you want to do. And then can you tell me any additional method or function you want to add to the matrix class?
Yeah, that's what I was trying to get to.
Yeah.
But then I was like, okay, how do we actually do this? Okay, provide. Okay, so what we want to know is, the function that I want to add is get neighbors.
Okay. Yep, that makes sense.
For a point. We want to return list of point x1 point y x minus 1 y x y is 1 and y minus 1. So this should be all the points around x neighbors. Okay. So, and we want to, okay. So it seems like let's see, we want to know the it's really not just, well, okay, sorry. So it seems like the matrix needs to have a dictionary of its islands that we will potentially add. So the point, okay, let's see here. For each point in the neighbors, we want to if the point is an island, we want to update the matrix island dictionary. No, we want to extend. Do we even need to track whether? Yeah, we need to know that the points that are in the island so that we can tell whether it's contiguous with another one, right?
Yeah. Basically, you want to track two things: whether if this is an island or not, and if this is visited place or not.
Yeah, if this is part of another island, right?
Yeah,
As you're going through, you're potentially connecting two islands together.
And then you don't want to visit the same place again, right?
We don't want to what?
We don't want to visit the same place again.
That's true. Yeah.
Yeah.
Okay, so matrix dot visited points. So we've got, yeah, because then we'll just keep going forever, right?
Yeah. Yes.
Okay. Because then we can say which island it's part of. Is that right? So we can know, the point can know which island it's part of. That seems helpful.
Mm-hmm. Do we need to have an island as a separate thing? So it seems like it is separate. So let's call island 2. What do you think's a point since it's first one? It's going to need some sort of identifier. How are we going to do that? Well, let's see. We call it with this is call the name to be, for now, point X. Okay, point has its own name.
I think the island needs a name so that we can. Well, no, is that true actually? Maybe it doesn't need a name. Maybe we could know if the island is the same reference, right? So yeah, maybe it doesn't need a name. Let's go without names for now because I don't like having to hack that in. Okay, so where were we? If the point is an island, then the point. Okay, so check the neighbor. So we're assuming that the point is already an island, right? So then we're going to say point island. Sorry, yeah, point island. Let's see, passive here. Point island and so we have to first check if it's seen, right? Forget. Visit the points. What do we want to do? We want to probably get it out. Do we want to? How's this going to help us? We're checking the neighbors, and if they are points, we want to add them to our island. But if we've already seen them, we shouldn't have to do any extra work, so we can just continue.
Yes.
Otherwise, if the point is an island, we want to append this point to the points island.
Uh-huh.
And then we should be able to continue, right? We've gone through all of them. Okay, but now I'm kind of lost as to where I was. Okay, so we wanted to, you wanted to count the islands in the matrix, really, right?
Yes.
That's the goal.
Yeah. So return value is just one single value.
It should return a single value, right?
Yep.
Def count islands. Okay, so let's assume that it's already finalized at this point, right? Like the matrix isn't getting any new rows. Now we're just going through. So for point in points, let's assume we have points that's being populated here. Rows dot get points or something maybe. But anyway, so we've got provided.
Oh, it's fine. Yep.
We needed. Okay, so for the points, where was I? For points, point and points. If point is island, I almost feel like this could be tracked separate. Well, let's start this way. If point is island, that should be a property that way. Point is an island, then get neighbors. Wait. Neighbors, yeah, so. Yeah, matrix should have neighbors of points. It's getting the neighbors, is it? It's like, well, no, it is getting the neighbors, but it's checking the neighbors.
Okay, checking the neighbors. Okay.
It seems like that should be a function in the matrix. The matrix should be able to check its neighbors. I'm going to move this up. Okay, so checking the neighbors in case it doesn't need. South. Okay, so if it's an island, then we're going to check the neighbors. Otherwise, it'll continue. Okay, good. So then let's see.
Okay, let me stop here. We're going to continue watching the video in the next session.